Okay, we're going to go over a quick troubleshooting procedure on the actual starting of the motor starter. There's not actually a problem in this, but I'm going to tell you what we should see, and if you're troubleshooting something and your bike isn't quite starting like it used to, or it won't start at all, this will give you a better idea where to look at. First, we're going to get a voltmeter. We're going to put this thing on voltage. This is actually auto ranging, so it's kind of hunting for if it's looking for AC or DC. First thing we're going to do, make sure that we've got decent battery voltage. Now, this right here, this piece here, is what you call a starter solenoid. It's nothing more than a relay, and what the relay does is it gets a signal from up at your handlebars, and it turns on and completes a path through the big wires to your starter. So through these two big wires, one of them is going to come from your battery, one of them is going to go to your starter. So what we're going to do is we're going to take one of these, we're going to put it on the ground, and we're going to check. I already know which one it is, but just to show you, this side I don't have any voltage. The reason for that is that's the side that's going to the starter. The starter's not engaged, so I won't have any voltage. Come on the other side, which there's a rubber boot right here, and you can see the nut terminal. If I put the positive lead of the voltmeter, I get 12.71. That's pretty decent for a battery. You'll get anywhere from probably 12.2 to 12.8, depending on when you ran it last. So I know my battery's good coming into the Bendix. You turn the key, hit the starter button, and on this side you only get like 7 or 8 or 9 volts. Your starter is going to be pretty weak. You should never have a voltage drop of under 10 on this. If you do, usually that'll tell you either your battery's junk or you might have an issue with this, but 9 times out of 10 your battery's going to be junk. Now if you walk up to it and you don't get any type of click or nothing out of it, first thing you want to do is turn it to your ohm reading, and you've got two connectors right here. Okay, so these two wires right here are actually what energize the coil to pull the contact down and allow a path of current. These are the signal wires. Now looking at these two, we have a green one and a yellow one. 9 times out of 10, the green one's going to end up being your ground. So you need to make sure you got a good ground. We put this on an ohm reading. We touch that inside, and then we come to a decent ground, and we need to make sure that we have a decent ground. If you look, you can see my resistance value is 0. It means I've got a pretty direct path. If you watch, and I barely touch, it looks something like that if you had a bad path. If there was absolutely no path, it's going to read OL, which is open line. It means there's not a path to ground, and you should always have a path to ground on this. So you want to make sure that's good. The other thing is you have your power wire. You want to turn this back over to volts, and what we're going to do is we're going to make sure we got a signal that's telling this to turn on. If you put your positive lead in there and you put your negative lead against the ground and you go to hit the start button, what you're going to see, obviously it's not going to turn on because I'm holding the signal wire, but we should get 12 volts. Okay, previously we tried to check signal here and we hit the starter button, we didn't get one. The reason we didn't get one was because it wasn't in neutral, and there's safety switches. One of them is the neutral switch, another one is the kickstand, I believe, and you need to make sure that both those switches are made. If they're not made, you're not going to get power here. So we're going to hook this up again one more time. We're going to hit the starter button and you're going to see 12 volts. 12.23. Now it's not quite 12.7, and the reason it's not 12.7 is because it goes through enough switches that there's a little bit of a voltage loss through every switch that's made. So that's not that big of a surprise. If you had like 10 volts, chances are this wouldn't magnetize enough in order to pull the contacts down. So we know we're getting signal. So that confirms that we're getting a signal. Okay, so we confirmed that we had power coming in, we confirmed we had ground coming in. So if we weren't getting this to turn on and we didn't have voltage when we turn the hit the starter button, basically if we know we're getting signal and we know we have power here, but we're not getting any power on this side when we hit the starter button, we know for a fact that our starter solenoid shot. And I'm just going to go ahead and hit the starter button, and you're going to be able to see momentarily that we have somewhere around 10 volts, 10 to 12. The starter will consume some voltage, but we just need to make sure there's a path. Okay, so what we did was, in order to get a better idea of what the starter is actually doing, I disabled the fuel pump, and how I did that was I just disconnected the wires up underneath the tank. I could access them without pulling the tank off. So if by chance you thought you had a battery that was going dead, or you thought your starter was going bad, this is how you're going to tell. If you have a voltage drop that goes down below 10, your battery is pretty much getting on its way out. You need to make sure that you charge it up, go riding for a day, come back, and repeat this test just to confirm it. But what I'm going to do is I'm going to hold it on the starter side of the solenoid. Notice I don't have voltage when I hit the starter button. It's going to complete a path between the two big wires, and we're going to see what our voltage drop is. Again, if it's below 10, your battery's junk. The bike isn't going to start because I disconnected the fuel pump. Now, you want to do that for about 4 to 5 seconds. You don't want to do it too much beyond that because your starter will get hot. If you do it for 10, 15, 20 seconds, you're really hurting your starter. But you can see that voltage never did drop below 10, and this battery's good. And that's how you check a battery without bringing it to a store. And let's be honest, if you're going to bring it to a battery store, they want to sell you a battery. So you really think they're going to tell you, nope, your battery's just fine when it gets even close to 10.5 or 11? It's just covering their own behind, I guess. But you're better off checking it yourself. One of your safety switches, or somewhere down the wire, or this wire, if you don't have a ground, well, you better get one. Trace it out, find out where it is, where you got the pinched wire. And if you don't have 12 volts here, your battery doesn't have enough voltage right off the bat to do any good. So that's in a nutshell how you do a quick check. Okay, so to recap, what we basically did was we checked 12 volts coming into your starter relay. That's direct from your battery. We made sure that we had a decent ground for the solenoid. We made sure we had incoming power to the solenoid, and we made sure that we didn't have too much of a voltage drop when the starter was actually engaged. The only thing beyond that we can do is if we were worried about a starter being bad, we can actually turn this back to ohms. We can touch right here, and again, you wouldn't want to put it on an ohm reading and touch across the power and the negative because you'll blow the fuse on your meter. But since this isn't energized, there is no path to power. We're going to touch it on the leaving side of the starter, and we're going to touch it to ground. We've got a clear path to ground. If we had an OL like that, that tells me either we have a break in this large wire or something burned up, or what will usually happen is your starter windings will actually burn up, and that's how you'll get an OL. So that's how you check your actual starter. And beyond that, it gives you a good direction of where to look at instead of just starting to throw parts at the thing.